There's a question that has haunted philosophers, scientists, and anyone who has ever lain awake at 3 in the morning, staring at the ceiling, wondering what they actually are. Not what they are made of, not how their body works, but what the experience of being them actually is. What consciousness is. Why there is something it feels like to be you. Why the lights are on inside your skull. Why you are not just a biological machine processing inputs and producing outputs in darkness, but an aware, experiencing feeling entity with an inner life that is as real to you as anything in the physical world. Science has answered an extraordinary number of questions about the universe, the composition of stars, the structure of DNA, the age of the cosmos, the nature of matter at the subatomic level. But consciousness, H, has remained stubbornly, almost embarrassingly, outside the reach of scientific explanation. We can map every neuron in a brain. We can watch which regions light up during different mental states. We can trace the electrical signals that flow between cells. And yet none of that explains why any of it feels like anything. Why the neural activity associated with seeing red produces the experience of redness, rather than just processing information about wavelength in the dark. This problem has a name in philosophy. David Chalmers called it the hard problem of consciousness. And it is hard, not because the science is incomplete in minor ways. It is hard because the standard scientific framework, the one that treats everything as physical processes following physical laws, does not obviously have room for subjective experience at all. The framework explains what brains do. It does not explain why brains experience. Into this gap, several serious scientists and theorists have proposed something radical, something that connects the mystery of consciousness to another great mystery of modern physics, quantum mechanics. And the theory they have developed suggests that your brain is not just a biological computer running on classical physics. It is a quantum device, and the quantum processes happening inside your neurons may connect you in ways that are physically real, rather than metaphorical, to the fundamental fabric of the universe itself. This is quantum consciousness theory, and even if you fall asleep before we finish, what you absorb will quietly rearrange something in how you think about what you are. Let's start with quantum mechanics, because you cannot understand the theory without understanding at least the outline of the territory it draws from. Quantum mechanics is the physics of the very small. Atoms, electrons, photons, the fundamental particles that make up everything. And at this scale, the universe behaves in ways that are genuinely, profoundly strange. Not strange in the sense of surprising or counterintuitive. Strange in the sense of violating the deepest assumptions that human intuition carries about how reality works. At the quantum scale, particles do not have definite properties until they are measured. An electron does not have a specific position while it is not being observed. It exists in a superposition, a kind of smeared-out probability distribution across multiple possible positions simultaneously. When you measure it, the superposition collapses and the electron appears in one specific location. But before the measurement, the particle genuinely inhabits multiple states at once. This is not a statement about our ignorance. It is not saying that the electron has a definite position and we just do not know what it is. The mathematics of quantum mechanics, confirmed by a century of extraordinarily precise experiments, says that the superposition is real. The multiple states are real. The electron is actually in all of them simultaneously until observation forces a resolution. There's also a phenomenon called quantum entanglement, where two particles interact in such a way that their quantum states become correlated regardless of the distance between them. Measure one particle, and you instantly know something about its entangled partner, even if that partner is on the other side of the galaxy. Einstein called this spooky action at a distance and spent years trying to explain it away. The experiments confirmed it anyway. Entanglement is real, it is non-local, and it suggests that the universe at its most fundamental level is connected in ways that classical physics has no framework for. Now bring these quantum phenomena into contact with the question of consciousness, and you get the central claim of quantum consciousness theory. What if the brain is not just a classical information processor running on ordinary chemistry? What if the quantum properties of matter, superposition, entanglement, coherence, play an active role in generating conscious experience? The most developed and scientifically grounded version of this idea comes from physicist Roger Penrose and anesthesiologist Stuart Hameroff. And their theory is called orchestrated objective reduction, which gets abbreviated to OR in the literature. Penrose came to the quantum consciousness idea from an unexpected direction. He was thinking about artificial intelligence and the nature of mathematical understanding. In his book, The Emperor's New Mind, published in 1989, he argued that human mathematical insight, the kind of intuitive grasp of mathematical truth that allows mathematicians to recognize whether a proof is right in ways that feel immediate and certain, cannot be replicated by any classical computational algorithm. His argument drew on Gödel's incompleteness theorems, which showed that any sufficiently powerful formal mathematical system contains true statements that cannot be proven within that system. Penrose argued that human mathematicians can see the truth of Gödelian statements in ways that no algorithmic system can, which means human consciousness must involve something that goes beyond classical computation. If consciousness is not classical computation, what is it? Penrose's answer was that it must involve some kind of quantum process. Specifically, he proposed that consciousness involves a physical process he called objective reduction, the spontaneous collapse of quantum superpositions according to a principle rooted in quantum gravity, the not yet fully developed theory that unifies quantum mechanics with Einstein's general relativity. Hameroff contributed the biological piece of the puzzle. He proposed that the quantum processes Penrose described happen inside structures called microtubules. Microtubules are protein structures that form part of the cytoskeleton of cells. They are the scaffolding that gives cells their shape and organizes their internal architecture. They are present in enormous numbers inside neurons, the cells that make up your brain. Hameroff proposed that the tubulin proteins that make up microtubules can exist in quantum superpositions, and that these superpositions are orchestrated by biological processes inside the neuron in ways that produce the objective reduction events that Penrose described. The orchestration is the biological regulation of the quantum process. The objective reduction is the collapse of the superposition. Orchestrated objective reduction, OR. When the superposition collapses, when the objective reduction event happens, Penrose and Hameroff proposed that this event is not just a physical state change. It is a moment of conscious experience. Each collapse event corresponds to a quantum of consciousness. The richness and continuity OAF, your conscious experience, comes from the extraordinarily rapid succession of these collapse events happening across the microtubules in your neurons, orchestrated into a coherent stream by the biological architecture of your brain. This is where the connection to the universe comes in, and this is the part that is simultaneously the most speculative and the most philosophically extraordinary element of the theory. Penrose's objective reduction is not just a process happening inside your brain. It is a process rooted in the fundamental structure of space-time itself. When a quantum superposition undergoes objective reduction, the collapse happens because the superposition creates a distortion in the fabric of space-time, a separation between two possible configurations of space-time, geometry that becomes unstable and resolves. The threshold for this instability is determined by the mass of the superposed system and the time over which the superposition is maintained. What this means is that every conscious moment, every orchestrated objective reduction event in your microtubules is physically connected to the geometry of space-time at the Planck scale, the smallest scale at which the structure of space-time has meaning. Your consciousness, under this framework, is not a product of your brain computing in isolation. It is a process in which your brain's quantum activity resonates with the fundamental quantum geometry of the universe itself. Your awareness is, quite literally, a feature of the universe becoming aware of itself through the particular quantum configuration of your neural architecture. This is not poetry, this is the actual physical claim the theory makes. And while it remains controversial, it is taken seriously by enough credentialed scientists and philosophers working at the intersection of physics, neuroscience, and philosophy of mind that it cannot simply be dismissed as mysticism dressed up in scientific language. The criticisms of OR are real and should be addressed honestly, because this is a theory in active scientific debate rather than settled consensus. The most prominent objection comes from physicists and biologists who argue that the brain is too warm and too wet to maintain quantum coherence. Quantum superpositions are extremely fragile. They are disrupted by interactions with the environment in a process called decoherence. In laboratory settings, maintaining quantum coherence requires extremely cold temperatures and careful isolation from environmental interference. The brain operates at body temperature, is filled with water, and is constantly subject to enormous thermal noise from biological processes. Critics argue that quantum superpositions in microtubules would decohere in femtoseconds, millionths of a billionth of a second, far too quickly to play any role in neural processes that operate on millisecond timescales. Penrose and Hameroff have responded to this criticism by pointing to biological research showing that quantum coherence is maintained in warm biological systems for longer than the simple decoherence argument predicts. Quantum coherence has been demonstrated in photosynthesis, where plants use quantum processes to transfer energy with extraordinary efficiency at room temperature. It has been observed in bird navigation, where certain species appear to use quantum effects in cryptochrome proteins to detect the Earth's magnetic field. The discovery that warm, wet biological systems can maintain and exploit quantum coherence has partially undermined the original strength of the decoherence objection, though the debate continues. Another criticism is that even if quantum processes do occur in microtubules, the theory does not actually explain why those processes would produce consciousness rather than just more physical computation happening at a smaller scale. This is essentially a restatement of the hard problem at the quantum level. Penrose's response is that objective reduction is fundamentally different from ordinary physical computation precisely because it is rooted in quantum gravity and involves a connection to space-time geometry that is absent from classical computation. Whether this response is satisfying depends on philosophical commitments that are themselves subjects of active debate. There are other quantum consciousness theories beyond OR that approach the problem from different angles. Henry Stapp, a physicist who worked with Werner Heisenberg, one of the founders of quantum mechanics, has developed a theory that places consciousness at the center of the quantum measurement process. In standard quantum mechanics, the collapse of the wave function, the resolution of superposition into a definite outcome, is triggered by measurement or observation. Stapp argues that the observer performing the measurement must be conscious, and that consciousness is therefore not a product of physical processes, but is instead a fundamental ingredient in the physical process of quantum measurement. Consciousness, in Stapp's framework, is what collapses the quantum wave function. It is not generated by the brain. It is what the brain participates in when it makes observations about the world. This idea connects to the broader interpretation debate in quantum mechanics. The Copenhagen interpretation, the most widely taught version of quantum theory, says that quantum systems exist in superposition until measured, but remains agnostic about what measurement actually means and whether the observer needs to be conscious. The von Neumann-Wegner interpretation, which Stapp draws on, takes the position that the chain of physical causation in a quantum measurement ultimately terminates in a conscious observer, and that consciousness is therefore irreducible from the quantum measurement process. Quantum physicist David Bohm proposed an entirely different framework called the implicate order, in which the universe has a deeper level of reality, an enfolded implicate domain from which the ordinary explicate reality we observe unfolds. Bohm proposed that consciousness and matter are both expressions of this deeper implicate order, that they are not separate substances in a dualist sense, but different aspects of a single underlying reality that is both physical and mental at its foundation. This framework has influenced a generation of physicists and philosophers interested in consciousness, even those who do not fully embrace Bohm's specific formulation. What all of these theories share is the intuition that consciousness is not an accident, not a byproduct, not an epiphenomenon that happens to arise in sufficiently complex information processing systems. They share the intuition that consciousness is connected to something fundamental about the structure of reality, that the universe is not simply a collection of particles following laws in the dark, but that awareness, experience, and the existence of an inner life are woven into the fabric of what reality is at its deepest level. Whether any of these specific theories are correct remains to be determined. The experimental evidence is suggestive but not conclusive. The theoretical frameworks are sophisticated but incomplete, particularly in their connection to a theory of quantum gravity that does not yet fully exist. These are genuine scientific and philosophical frontiers where the questions are clear and the answers are still being worked out. But here is what you can carry with you as you drift towards sleep. The universe produced you. Out of quantum fields and fundamental particles and billions of years of cosmic evolution, the universe assembled configurations of matter that became galaxies, stars, planets, oceans, life, brains, and finally, the experience of being aware. Whether consciousness is a quantum process connected directly to the geometry of space-time, or whether it emerges from classical neural computation in ways that merely feel mysterious, the fact of your awareness is one of the most extraordinary things in the known universe. You are the universe looking at itself, wondering about itself, trying to understand what it is. That wondering, that reaching toward understanding, is itself part of the phenomenon. The question and the questioner are made of the same thing, and whatever that thing ultimately is, at the quantum level or beneath it, it is stranger and more beautiful than any framework we have yet built to contain it. Close your eyes. The universe is thinking through you about what it means to think.